In a world increasingly shaped by climate change, rapid urban expansion, and a growing awareness of our ecological footprint, the concept of eco-architecture of the future has shifted from a visionary ideal to a global necessity. Today, architects, scientists, engineers, and environmental thinkers are merging creativity with sustainability to reimagine how we design, build, and inhabit the spaces around us. Eco-architecture is no longer just about green buildings. It is about designing a living, breathing infrastructure that regenerates the environment, supports biodiversity, and nourishes the people who use it. As more people search for sustainable solutions, eco-architecture emerges as one of the most powerful trends shaping the next era of human civilization. The eco-architecture of the future centers around several core principles: carbon neutrality, energy efficiency, circular design, renewable materials, climate resilience, and harmonious integration with natural ecosystems. But future architecture goes further. It aims not just to reduce harm, but to create positive environmental impact. It envisions buildings that produce more energy than they consume, structures that purify the air, skyscrapers covered in lush vegetation, floating cities powered by clean energy, and communities designed to thrive in a constantly changing climate. This shift from sustainability to regeneration is what makes eco-architecture one of the most transformative movements of our time. At the heart of future eco-architecture lies the transformation of materials. Traditional building materials like concrete and steel contribute massively to global carbon emissions. But architects of the future are turning to bio-based, low-carbon, and even carbon-negative materials that not only reduce impact but actively improve environmental health. Innovations like cross-laminated timber, mushroom mycelium bricks, algae-based bioplastics, hempcrete, bamboo composites, and recycled ocean plastics are redefining construction. These materials are renewable, biodegradable, durable, and in many cases, stronger and lighter than their conventional counterparts. Buildings made from these materials store carbon instead of emitting it, helping reverse the damage caused by centuries of industrialization. As these materials scale globally, they will become the foundation of every eco-city of the future. Energy is another pillar of eco-architecture's transformation. The buildings of the future will operate as self-sustaining ecosystems powered by renewable energy technologies integrated directly into their structure. Solar panels will no longer be mere rooftop additions. They will be embedded into windows, facades, and roofing systems using transparent photovoltaics and flexible solar skins. Wind turbines integrated into building edges and skyscraper gaps will harness high-altitude winds. Geothermal systems will cool and heat entire neighborhoods with minimal energy use, and smart energy storage solutions will ensure uninterrupted power supply. With these advancements, buildings will evolve into micro power plant plants, exporting surplus clean energy and contributing to grid stability. This decentralized model of energy production will play a crucial role in reducing dependence on fossil fuels and making future cities net zero. Another defining feature of eco-architecture is the integration of nature as a central design element rather than a decorative afterthought. Future buildings will be designed as vertical forests, living green walls, rooftop farms, and biodiverse habitats that support wildlife while improving human well-being. Urban areas will no longer be sterile concrete jungles. They will be green, lush, and teeming with life. Trees, shrubs, and native plants will become part of the building's identity, reducing air pollution, lowering heat, and providing natural insulation. Biophilic design, which focuses on creating a deep connection between people and nature, will dominate architectural trends. Research shows that access to greenery improves mental health, boosts productivity, and reduces stress. As cities become denser, integrating greenery into architecture will not only create healthier environments, but also restore ecological balance in rapidly urbanizing regions. Water conservation is another crucial pillar of the eco-architecture of the future. With growing concerns over water scarcity and climate-induced droughts, sustainable water management will become a standard feature in every building. Rainwater harvesting systems, atmospheric water generators, greywater recycling technologies, and natural filtration systems will allow buildings to operate with minimal water waste. Roofs and facades will collect rainwater and direct it into purification systems. Smart sensors will monitor usage and detect leaks, ensuring optimal efficiency. Bioswales, green roofs, and permeable pavements will manage stormwater naturally, reducing flood risks and supporting groundwater recharge. In coastal or flood-prone areas, amphibious buildings designed to float during extreme weather will offer resilience against sea level rise. The architecture of the future sees water as a precious resource woven intelligently into design rather than treated as an afterthought. A major evolution in eco-architecture is the rise of smart technology and artificial intelligence as essential components of sustainable design. With the rapid growth of smart cities, buildings will evolve into responsive, intelligent systems capable of adjusting their environments in real time. Sensors will monitor temperature, humidity, air quality, lighting, and occupancy to optimize energy performance. Automated shading systems will adapt to sunlight, smart windows will regulate heat transfer, and AI-driven HUC systems will minimize energy waste. Data will guide maintenance, detect inefficiencies, and extend the lifespan of building systems. This integration of technology creates not only energy-efficient structures but also healthier living environment. The future of eco-architecture will rely on the synergy between sustainable materials, renewable energy, and intelligent systems that constantly learn and improve. Transportation integration is another emerging aspect of eco-architecture. As cities aim to reduce carbon emissions from vehicles, future buildings will be designed with sustainable mobility solutions incorporated into their structure. This means more bicycle-friendly facilities, electric vehicle charging stations, solar-powered transit hubs, pedestrian-focused layouts, and mixed-use spaces that reduce commuting needs. Buildings will be located strategically near public transportation, and many developments will encourage walkability by integrating shops, offices, parks, and residences into single, compact communities. Autonomous electric vehicles and drone delivery systems may even shape how buildings are structured, with designated landing pads or docking stations. Eco-architecture aims to shrink the distance between living, working, and leisure spaces, promoting low-carbon lifestyles and reducing dependence on fossil fuel transportation. Climate resilience will also define the architecture of the future. As extreme weather events become more frequent, buildings must not only be sustainable but also adaptable and durable. Future eco-architecture will prioritize designs that withstand heat waves, floods, storms, droughts, and rising sea levels. This includes floating buildings, elevated infrastructure, modular structures that can be relocated, and homes with passive cooling systems that function even during power outages. Materials will be selected for their resilience to humidity, heat, and erosion, ensuring longevity in changing climate. Communities will be designed with integrated green buffers to absorb storm surges, prevent erosion, and enhance biodiversity. Eco-architecture therefore plays a dual role, minimizing environmental impact while providing practical solutions to the challenges of a warming planet. One of the most exciting trends shaping the eco-architecture of the future is the rise of regenerative communities and eco-cities. These are not just isolated sustainable buildings, but entire ecosystems designed to function in harmony with the natural world. Eco-cities integrate renewable energy grids, extensive green spaces, eco-transportation networks, waste-to-energy systems, and food production into their core infrastructure. They prioritize walkability, community engagement, and circular economies where waste becomes a resource. Examples already emerging around the world include smart eco-districts, carbon-positive communities, and floating cities designed to adapt to sea level rise. These urban visions embody the highest potential of eco-architecture, creating spaces where people live sustainably without sacrificing comfort, convenience, or quality of life. Waste reduction is another critical component of future architectural design. Traditional construction methods generate vast amounts of waste, but the eco-architecture of the future embraces circular construction practices. This includes modular building systems that allow components to be easily assembled, disassembled, and reused. Prefabricated elements will reduce waste on job sites, shorten construction time, and lower environmental impact. Upcycled materials, 3D printed structures using recycled waste, and buildings designed for deconstruction will reshape how we think about architectural life cycles. Instead of ending in landfills, building materials will enter new life cycles, contributing to a circular economy that saves resources and reduces carbon emissions. Food production is another frontier merging with future architecture. As populations grow and arable land becomes limited, buildings will increasingly integrate urban agriculture, turning unused surfaces into productive landscape. Rooftop farms, vertical gardens, hydroponic towers, and aquaponic systems will allow apartments, commercial buildings, and schools to produce fresh food on site. This shortens supply chains, reduces transportation emissions, and enhances food security. In many eco-cities, food-producing buildings will become community hubs where residents can grow and share produce. This fusion of architecture and agriculture represents a new form of urban sustainability that blends environmental responsibility with community well-being. The eco-architecture of the future is also deeply connected to cultural identity and local traditions. Sustainable design does not follow a one-size-fits-all approach. It respects the climate, materials, and heritage of each region. Architects are revisiting indigenous construction techniques which are naturally sustainable, climate responsive, and adapted to local ecosystems. By blending traditional knowledge with modern technology, future buildings will become culturally meaningful, environmentally responsible, and visually inspiring. This approach not only preserves heritage but also fosters resilience, as many traditional methods were specifically designed to cope with local climate conditions. Perhaps the most compelling aspect of future eco-architecture is how it redefines human well-being. The buildings we inhabit influence our mental health, physical comfort, productivity, and emotional connection to the world. Eco-architecture creates environments that prioritize natural light, clean air, thermal comfort, and sensory harmony. Spaces designed with biophilic principles, incorporating organic materials, natural patterns, and greenery have been shown to reduce stress and enhance cognitive performance. In the eco-cities of future, well-being is not a luxury but a foundation of design. Schools will incorporate nature to support learning, offices will integrate greenery to boost creativity, and homes will be sanctuaries that foster calm and connection. As the world continues to embrace sustainability, eco-architecture will become not only popular but unavoidable. Governments, corporations, and communities are already committing to net zero goals, green building standards, and climate-resilient policies. Millennials and Gen Z, more environmentally conscious than any previous generation, are driving demand for sustainable homes, offices, and public spaces. Social media amplifies eco-architecture trends, inspiring millions to rethink how they live and interact with their environments. As these forces converge, eco-architecture will become the defining aesthetic and ethical movement of the century. In conclusion, the eco-architecture of the future is more than a trend. It is a global revolution reshaping how humanity builds and inhabits the planet. From carbon-negative materials and renewable energy systems to smart technology, biophilic design, and climate-resilient communities, eco-architecture offers a blueprint for a regenerative, harmonious future. It imagines cities that function like forests, buildings that work as ecosystems, and communities built on sustainability, resilience, and collective well-being. As we move deeper into an era defined by environmental challenges, eco-architecture stands as a beacon of hope, a reminder that with innovation, creativity, and determination, we can build a future that is not only sustainable but truly regenerative. The eco-architecture of the future is not just about saving the planet, it is about redesigning the human experience in a way that supports both our world and our future generations.